Let's go. Give me them toes. Check it out. Check it out. Homie Holmes going. Buckets. No, it wasn't. All right. We are on 9-4, 3 videos to go. 1 of 3, here we go. But this is 9-4 part 2. Since this one is a bit of a booga, and we don't need to know this dude on the AP exam, we're going to skip the booga. All right. And the ones that we really want to make sure we're able to do here for the AP exam are examples 10 and 12. Okay. So let's take a look at these bad boys. Okay. For a power series. Remember why it's a power series? Because X in it. Okay. That represents this dude right here. I need a pen. Oh, I got a pen. That dude right there, centered at C equals 0. So it's Maclaurin. Now, they won't obviously give us a hint right here, okay, on the actual AP exam. But we could do this a really, really long way or a quick way, okay, because they're asking us right now to find the radius and the interval of convergence for this right here. Now, the light bulb that we would hope to go off is, hey, that looks like this bad boy, right? And this is one of those guys that we have memorized. Correct? What is it that we have memorized? Well, we have memorized that 1 over 1 minus x is equal to 1 plus x squared plus x to the third plus plus x to the n plus right? Or the sum from n equals 0 to infinity of x to the n, right? So that's something that we have memorized. And if I could use it somehow for this, I'd be good to go. Now, one thing we want to realize, and this is the hint right here, that if we do have 1 over 1 minus x, which is equal to 1 minus x to the negative 1, and I take the derivative of that bad boy, right? So if I take the derivative of this power series we want to have memorized, that'd be negative 1 to the 1 don't you dare touch the inside, to the negative 2, that changed to a negative 1, which makes that positive, which, believe it or not, is this, right? So how about it? So this power series, if I take the derivative of it, I get this. So guess what I could do? I could just say that is equal to the derivative of this power series. So let's take the derivative of this bad boy, which would be the derivative of 1, which would be 0. The derivative of x would be 1. The derivative of x squared would be 2x. The derivative of x to the third would be plus 3x squared plus ... plus. What the heck is the derivative of x to the n? Well, that's drop that n and subtract 1 from it plus ... How about it? That right there happens to be my general term for 1 over 1 minus x squared. Not too bad, right, class? And then from there, what do I need to do? So now we need to find the interval and the radius of convergence. Now I'm going to try to keep that guy memorized because I'm going to have to zero that whole thing. So it was n, let's write it down. It was n x, I just have to take the derivative, right? To the n minus 1. And that's going to be the sum from n equals 0 to infinity, right? We put a 0 in that bad boy, it doesn't work. So we're actually going to start from 1 this time, right? Because we kind of had a derivative, we kind of skip a term. If I plug a 1 in there, I start out with a 1, right? Because it'd be x to the 0. And then I put a 2 in there, and I get a 2x, which was my term, right? And then I put a 3 in there, I get 3x squared. And that's exactly what I had. So let's go ahead and do the ratio test, right? Because it's asking me to find the radius in the interval of convergence. So we go ahead and we do that bad boy, and we have an n plus a 1, x to the n plus 1 minus 1, all over, right? I just have to divide these guys. I can skip that step to the n minus 1. So if I simplify here a little bit, we go the limit as x approaches infinity. I have an n plus 1 that ends up being x to the n on the top. On the bottom, I have an n and I have an x to the n times an x to the negative 1. Ooh, snappy-dee-dappy-dee. Do not forget my absolute values, right? And we have to do it less than 1 because that's what it's going to tell me it converges to. And then I'm going to skip a step. Well, this right here would really go to the numerator, and the limit of that would be 1. So then I have that is equal to, that is just going to be the absolute value of x is less than 1. And I'm going to do that from negative 1 to 1. And then I just have to check the endpoints. Okay, now remember, checking the endpoints, you plug it back into there. That's something you should do on your own time. I'm going to give you the answer because it gives us nothing different. You get a little diverge. Make sure you test that. Make sure you're good to go. All right, make sure you're doing these little things that I'm asking you to do so you're ready for a pop-up quiz. If we have a Pop quiz. Pop quiz. Just kidding. Here we go. I think we just maybe had a quiz. All right, let's keep rolling. What about this next one? Find a power series that represents the natural log of 1 minus x centered at c equals 0. Well, this actually is somewhat familiar. And if I think about it, if I take the derivative, right, if I take d dx of 1 over x, that would be 1 over 1 minus x. How about it, right? That's totally legit. And this I have memorized, right? This is that power series that I have memorized. So the derivative of it is equal to 1 over 1 minus x. So that means that would be equal to 1 plus x squared plus x to the third plus da-da-da plus x to the n plus da-da-da. Okay, so how could I use that to help myself out here? Now, you wouldn't be given that hint, right, on the AP exam. But hey, if I take the antiderivative of this, I end up with the natural log. So let's take the antiderivative of all that stuff, right? And then I'm going to get the natural log. Okay, so the antiderivative of 1 would be x, right? The antiderivative of x would be 1/2 x squared. What would the next one be? It'd be 1/3 x to the third plus 1/4 x to the fourth, right? Plus da-da-da, plus what would this one be? Well, I'm going to add 1, right? So it'd be x plus 1, but then I'm going to divide by that n plus 1 plus dot, dot, dot. So how about it? That works out beautifully, and now they ask me for a radius of convergence and a interval of convergence. Believe it or not, since these all are Maclaurin, excuse me, and they are all centered at 0, well, duh, they're Maclaurin, but they all have to deal with this guy here. If you take derivatives or antiderivatives, they're always going to be centered or have an interval of convergence from -1 to 1. The only thing that could maybe change is the endpoint. So let's go ahead and check the endpoints here. Didn't tell you that last one because I wanted you to practice doing it, but here we go, right? This is my little sum here. Am I going to start at 0 on this bad boy? Definitely start from 0 to infinity, and I have x to the n plus 1 over n plus 1. So for now, I just got to test this, so that just means I'm going to plug a -1 in there. So let's test x equals -1. So I don't know if I have enough room, but we're going to challenge it. So I get -1 to the n plus 1 all over n plus 1. Right, so we're going to test this guy. We got the little sigma dude there. This would be an, okay. So that is an AST, right, class? Where check one is you throw out that alternator and you see if the nth term test goes to 0. And guess what? It does. Step 2 is without the alternator. Is it a decreasing sequence? For sure this bad boy is. So that means this converges by the alternating series test. So this is the first one we've done in a while that actually that bad boy will be a bracket there. Now, I can't erase, so I'm going to try to keep on going here in blue though. And we have to test 1. So let's do this over here. Let's go with the sum n equals 0 to infinity. Sorry, it's all jumbled. We're going to put a 1 in there, which would be 1 to the n plus 1 over n plus 1. Well, 1 to the n plus 1 is just going to be 1, so we can get rid of that bad boy. And then everybody should know what this bad boy does, right? That definitely looks like 1 over n. 1 over n diverges, but remember, it's a harmonic p series, what I'm comparing it to. It looks like I could do a direct comparison, but that doesn't help me out in this case. Remember, we've talked about this over and over again in class, so make sure you finish this to make sure you are okay. What test do we use back there at home? LCET, right? You use the limit comparison test, right? And since that diverges, and when you do the limit comparison test, which is 1 over n plus 1, you get a limit that approaches EG. And if it approaches EG, then that means it's finite and positive. And since it's finite and positive and 1 over n diverges, that series diverges, you know that this series diverges. So that would be a parentheses. All right? Now let's keep rolling. I think we're going to do a little practice AP question here, right? So this is really big time because you're going to take a practice AP here really, really shortly. Okay, so let's make sure we're good with all this stuff. Kind of ties it all together, right? Home's chilling on the flow. All right, write the first 4 non-zero terms and the general term of the Taylor series. So this is actually an old AP question. And that looks really familiar to this, kind of, sort of. Can you write it like that to help yourself out? Well, believe it or not, I think I can. I think that is equal to 1 over 1 minus negative x squared, right? That's totally legit, right? 100% equal to that, guy. So that means I can use this cheat to my advantage. And the cheat is 1 plus x plus how far do we have to go? First 4 non-zero. 1, 2, tree. 4, and it says a general term. So guess what? I'm going to use that. And you know what a time saver this is? Try doing that the long way. No way, Jose. Thank you. Right, where all I got to do now is this guy up here is equal to Ichi 1 plus, I'm going to put in a, oh, snappity dappity, shame on me. That square should be on the inside. That's actually very important. So it should be 1 over 1 minus negative x squared, right? Because then that's 1 over 1 minus u or x. All right, so it's 1 plus. I'm going to put a negative x squared in there. Negative x squared. Oops. Yep, just like that. Okay, plus, I'm going to put a negative x squared into that bad boy. Plus, I'm going to put a negative x squared into that bad boy. Plus, plus, I'm going to put a negative x squared in for that bad boy. Okay, plus dot, dot, dot. Now let's simplify this. That'd be 1 minus x squared plus x to the 4th minus x to the 6th. Definitely an alternator going on. Plus dot, 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 plus, that'd be negative x to the 2n power, right? And I actually could share that negative to both. So that could be a negative 1 to the n times x to the 2n, which that kind of is nice because it shows that alternator going on. Okay, is that all I had to do? Booyah, donezo, sweet. On the AP exam, that's 1, 2, 3 points just for getting that right. And I think everybody in here would kind of be capable of that. But make sure you have your dudes memorized, right? Let's get rid of that bad boy and keep rolling, rolling, rolling. All right, here we go. Ooh, snap. Nope, don't want that. Okay, let's get up here. Does the series found in part A converge at x equals 1? Well, here we go. Oh, come on. Come on. Okay, I'll go back there. Come on, get me back there, please. Sorry, class. Pause. All right, I think we got it covered. Please, please, tell me you're right. Sweetie. All right. So here we go. We're part D. And the series was n equals 0 to infinity. What do we got here? I'm going to have to look back at my notes because I had to erase it. We get, and I wrote it like this. It's kind of nice because you can see the alternator, x to the 2n. Okay? Does this guy converge when x equals 1? Okay, so that just means I got to put a 1 in for x, and let's check this bad boy, right? It's kind of like checking endpoints, correct? After all, it was that I was comparing it to this bad boy, right? And it is Maclaurin, so we just really have to check the endpoints here. So let's go ahead and do this. We have negative 1 to the n. It's going to be 1 to the 2n. Well, 1 to the 2n is just 1, right? It doesn't matter what that is, so this is kind of like an alternator. However, it doesn't even pass the nth term test, right? If I take the infinity, it actually oscillates, right, between a negative 1 and a positive 1. So it does not equal 0. So then we say this bad boy diverges by the nth term test. So that's how nice the AP helps you out when you can recognize how to attack a problem, right? And a lot of these are brand new to us, right? Because we don't do these problems over and over again. And that's why that AP exam is tough. They'll ask a question a little bit different way and see if you can handle it, okay? So that diverges. So boom, that question's done. And believe it or not, check, it was only worth a point. We are fo so far. All right, here we go. Part C, the derivative of arctan. Oh my gosh, it's a trig, so you guys are all freaking out. Okay, the derivative of arctan is this bad boy right there, right? The first 4 non-zero terms of the Taylor series for arctan about x equals 0. About, whoa, so that means what's arctan of 0? Just curious. So that would be, remember, arc or inverse means it's an angle. Okay, so when does tangent equal 0? At what angle? And it does at 0, right? Because we have a restriction for arctan that has to be in the first or the fourth quadrant. Okay, I think I need a sip of water. Okay, so it says that the derivative of arctan is this. Well, if the derivative of arctan is this, that means arctan would be equal to the antiderivative of 1 over 1 plus x squared, right, class? And we know the first, what's it ask? First 4 non-zero terms. And we know the first 4 non-zero terms of 1 over 1 plus x squared, right? We did that last one, and I wrote it down there. It's up above in your notes, right? It's just this bad boy right here. Do they ask for a general term? Oh, they don't. So we can just focus on those. So all I got to do here is take an antiderivative, right? Let's take the antiderivative, and it's going to give me arctan. And we get the antiderivative of 1 is x. The antiderivative of negative x to the squared would be negative x to the third over 3, right? Plus x to the fifth over 5 minus x to the 6 over 6. There you go. How about it? 2 points. Oh, snap. Plus c. But that's why I did that earlier. It says we have an initial condition. And if you plug in a 0 for x, what do you get for c? You put a 0 in for all of those x's, and c equals 0. So there we go. And that c is kind of important because, right, that could have been a constant if we had a different value that came up, if you didn't check the initial value, and then you wouldn't have had the first 4, right? This would have been the 5 because that would be a constant, and we usually have constants start out for us, okay? Hopefully okay. That's worth 2 points. Oh, I already did that, all right? So we're up to 6. So what did that mean? In 2000, and oh, I had to stay home the other day. Poor KK was sick. All right. Use the series found in part C to find a rational number A. Okay, so we're going to take our time here on this. We have yet to do this in this class. Okay, this stands for an error. Okay, that's an error. That is the approximate minus the actual. Okay, and remember, that was always our remainder in the past, or we're going to call it our error bound going forward. And I'm going to make sure that we take our time on this, okay? And it says that use the series found in part C to find a rational number A such that A minus arctan, that again is the actual, that's an approximate. And we need it to be less than 1 over 10, and we have to justify our answer. Okay, so let's write down what our arctangent of x was again, okay? And it was x minus 1/3 x to the third plus 1/5 x to the fifth minus 1/7 x to the seventh. Now they're asking me to find an error. Now we have a rule here in AP Calc, okay, that your error bound, okay, or your remainder is always, if they're asking us to find it less than 10, then this guy right here represents, I got it right here, the first unused term is your error bound. Now, what does it mean as our first unused term? Well, what we're going to do is we're going to go through our terms, and we're going to find out which one of those terms gives me something less than 1/10. And then I'm not going to use that bad boy, okay? And that is what we would call our error or our error bound. All right, so let's find out what this would be, okay? So how do I figure this out? Well, this is our approximation, correct, class? So we're going to find out what type of error we're dealing with. So I'm going to start with x, and I'm going to plug in a 3/4. Okay, class, is 3/4 less than 1/10? No way, Jose. So that means I've got to go further. Remember, it's going to be my first unused term. And your first unused term is going to be whichever term gives us a number that is less than 1/10. So let's go to the next bad boy. And whenever we do these, right, it's absolute values, okay? So we're going to just worry about the positive. All right, let's go to the next guy, this guy right here. And Swedish, I obviously ran out of ink. And I've already got this guy going. Let me find my pen. All right, got it, class. I'm going to apologize if this is a little bit messy, but we are going to try our best. All right, so let's take this next term, and I'm going to do the absolute value of it. So all I care about is 1/3, 3/4 to the third. Now, believe it or not, when you do this on the AP exam, a lot of the times it's non-calculator, okay? So believe it or not, you'd have to work through this guy. That'd be 1/3, 3 to the third, which would be 27 over 64. What the heck is that? Well, that's 27 over, what would that be? I did my answer. I'm going to save us some time. What do we get here when we get that bad boy? I got 1/3 1/3. Maybe I don't have it 3 times. That shouldn't be that hard. That's 196. 192. 192. Is that less than 1/10? Well, how could you figure that out? Well, let's just multiply the bottom. Let's just get a common denominator, right? I can multiply it by, I want to get the common denominator would be 192. Let's just use 190. So I'm going to multiply the bottom by 19, which gives me 190, and the top by 19. Ooh, this guy is still smaller. All right, so let's try the next dude, and I'm running out of space. So I'm going to erase what I got going on there, class. Okay, and I've got my notes here. So the next term is 1/5, and I'm going to multiply that by 3/4 to the 5th. Now this would take some major old school math, and this teacher I know just made this look like the 2008 test. So we're going to actually do the 2008 test in class to get some good practice. But I got the answer to that bad boy. That is 243 over 5,120. And is that less than 1/10? Well, that is equal to, let's get a common denominator. I'm going to multiply the top and the bottom by 512. And is it, ooh, that is bigger. So that's checkmate. So believe it or not, now it's all about just writing a statement. That's really, and that's the justifying part of this problem. So here we go. I'm going to write out my statement. I'm going to try to write it as neatly as I can, okay? Whoops. All right, so since the series is an alternating series, which it is, and this error-bound technique works so far with what we're doing only for alternating series, okay? And decreases, it's kind of like the alternating series test, decreases with our limit as n approaches infinity going to 0, the error A minus arctangent of 3/4 is going to be less than, what was the answer we got there? It was 243 over 5120. So this is a number that they're going to be checking. Okay, now we've got just, it's going to be really fast. One last page to go. I think they're really, really cool problems when we look at the next page, and they come up all the time as multiple choice. And we don't want to miss those multiple choice, so I'm going to get myself a new page, and let's get ready to roll. All right, so here we go. These are some of my favorite problems in AP Calc, because if you know your cheats, they're nice and easy, Japanese. Where's my pen? Now I can't even find Swedish. All right, here we go. So first story of the day is you got to hit pause. You got to try your best here. That looks like something we know. What does it look like? Hit pause. Boom. Unpause. Okay? That looks to me like cosine, right? Because what is cosine x? Cosine x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus, minus x to the 6th over 6 factorial plus da-da-da, right? It looks exactly like it. The only difference is wherever there is an x, there is a pi. There's a pi, right? Totally, right? I mean, just x. So that's cosine with a pi in for x. So all you got to do, what's cosine of pi? -1. You better not do all that and get that wrong, right? That's it. Believe it or not, how awesome is that? That's pretty cool if you ask me. That problem at first look looks impossible. No. Not if you know your rules, okay? So here we go. Once again, let's look at B. Take a quick pause. And what does B look like? Pause. Unpause. All right. That to me looks like e to the x to me. 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial plus da-da-da plus da-da-da-da-da. Okay, that does. But then what would x be? Well, that's a dead giveaway right there, right? Squared to the third to the fourth. So that means I just have to do e to the natural log of 4. And I know my rules of logs. If it's e, log base e, because that's what a natural log is, 4. My answer is just 4. Come on, Mr. T. Give me some harder stuff than that. All right, here we go. Let's finish this stuff off. All right, C. What does C look like? A little bit tougher. Why don't you pause, unpause, and see if you can get that entirely on your own. That would be sweet. All right, pause, unpause. That to me, 100 looks like a little signage, right? That looks like sign, but a little bit more involved than just plain signage, right? Because how does sign start? Starts at X, but then we have these odds, right? That's how I knew it was sign. But they're adding some other stuff in here, right? I got like a 2 out in front of all that. Well, how the heck would I handle it if there's a 2 out in front of all of that, right, class? How would I handle that? Well, all right. First, let's just handle what's going on. And I don't know about you, but look, that sign right there, right? Wherever I see an X, there's a pi over 6. So let's handle that. Pi over 6. But what do I notice? There's literally a 2 in front of all of those. Let's put a 2 there, right? Not bad. What sign of pi over 6? Well, that's just a half, Mr. T, and 2 times a half is easy, right? So donezo. Do me a favor. I know it's getting late in the year, a little senioritis kicking in. When I say do your worksheets and struggle through them and go through the solutions at home, please do it. Please have them done when you walk in so we can just, boom, just jet. We got one last section to go, 9-5, aloha.